The OSI. The Open Systems Interconnections Reference Model is a layered abstract representation created as a guideline for network protocol design. The OSI model divides the networking process into 7 logical layers, each of which has a unique functionality and to which are assigned specific services and protocol. In this model, information is passed from one layer to the next, starting at the application layer on the transmitting host, proceeding down the hierarchy to the physical layer, then passing over the communications channel to the destination host, where the information proceeds back up to the hierarchy, ending at the application layer. The figure depicts the steps in this process. The application layer. Layer 7 is the top layer of both the OSI and TCP/IP models. It's the layer that provides the interface between the applications we use to communicate and the underlying network over which our messages are transmitted. Application layer protocols are used to exchange data between programs running on the source and destination hosts. There are many application layer protocols, and new protocols are always being developed. The human network generates data. The application layer prepares human communication for transmission over the data network. People create the communication. Software and hardware convert communication to a digital form. Application layer services initiate the data. Each layer plays its role. The network and messages are sent to people. And the application layer receives data from the network and prepares it for human use. Although the TCP/IP protocol suite was developed prior to the definition of the OSI model, the functionality of the TCP/IP application layer protocols fit roughly into the framework of the top 3 layers of the OSI model: application, presentation, and session layers. Most TCP/IP application layer protocols were developed before the emergence of personal computers, graphical user interfaces, and multimedia objects. As a result, these protocols implement very little of the functionality that's specified in the OSI model presentation and session layers. The presentation layer. The presentation layer has 3 primary functions: coding and conversion of application layer data to ensure the data from the source device can be interpreted by the appropriate application on the destination device, compression of data in a manner that can be decompressed by the destination device, encryption of the data for transmission, and the decryption of data upon receipt by the destination. Presentation layer implementations are not typically associated with a particular protocol stack. The standards for video and graphics are examples. Some well-known standards for video include QuickTime and Motion Picture Experts Group, or MPEG. QuickTime is an Apple computer specification for video and audio, and MPEG is standard for video compression and encoding. Among the well-known graphic image formats are Graphics Interchange Format, or GIF, Joint Photographic Expert Group, or JPEG, and Tagged Image File Format, or TIFF. GIF and JPEG are compression and coding standards for graphic images, and TIFF is a standard coding format for graphic images. The session layer. As the name of the session layer implies, functions at this layer create and maintain dialogues between source and destination applications. The session layer handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. Most applications like web browsers or email clients incorporate functionality of the OSI layers 5, 6, and 7. The most widely known TCP/IP application layer protocols are those that provide for the exchange of user information. These protocols specify the format and control information necessary for many of the common internet communication functions. Among these TCP/IP protocols are Domain Name Service Protocol (DNS) is used to resolve internet names to IP addresses. Hypertext Transfer Protocol (HTTP) is used to transfer files that make up the web pages of the World Wide Web. Simple Mail Transfer Protocol (SMTP) is used for the transfer of mail messages and attachments. Telnet, a terminal emulation protocol, is used to provide remote access to services and networking devices. File Transfer Protocol (FTP) is used for interactive file transfer between systems. The protocols in the TCP/IP suite are generally defined by request for comments or RFCs. The Internet Engineering Task Force maintains the RFCs as a standard for the TCP/IP route. Application layer software. The functions associated with the application layer protocols enable our human network to interface with the underlying data network. When we open a web browser or an instant message window, an application is started and the program is put into the device's memory where it is executed. Each executing program located on a device is referred to as a process. Within the application layer, there are two forms of software programs or processes that provide access to the network, application, and services. Network-aware applications. Applications are the software programs used by people to communicate over the network. Some end users' applications are network-aware, meaning that they implement the application layer protocols and are able to communicate directly with the lower layers of the protocol. Stack email clients and web browsers are examples of this type of applications. Application layer services. Other programs may need the assistance of application layer services to use network resources like file transfer or network print spooling. Through the transparent of the user, these services are the program that interface with the network and prepare the data for transfer. Different types of data, whether it is text, graphics, or video, require different network services to ensure it is properly prepared for processing by the function occurring at the lower layer of OSI model. Roles of the transport layer. Purpose of the transport layer. The transport layer provides for the segmentation of data and the control necessary to reassemble these pieces into the various communication streams. Its primary responsibilities to accomplish this are tracking the individual communication between applications on the source and destination host, segmenting data and managing each piece, reassembling the segments into streams of application data, identifying the different applications. Tracking individual conversations. Any host may have multiple applications that are communicating across the network. Each of these applications will be communicating with one or more applications on remote hosts. It is the responsibility of the transport layer to maintain the multiple communication streams between these applications. Segmenting data. As each application creates a stream, data to be sent to a remote application. This data must be prepared to be sent across the media in manageable pieces. The transport layer protocols describe services that segment this data from the application layer. This includes the encapsulation required on each piece of data. Each piece of application data requires headers to be added at the transport layer to indicate to which communication is associated. IP version 4 packet header. This course will consider these three key fields: IP source address, IP destination address, time to leave or TTL, type of services, TOS, protocol, and fragment offset. IP destination address. The IP destination address field contains a 32-bit binary value that represents the packet destination network layer host address. IP source address field contains a 32 binary value that represents the packet source network layer host address. Time to leave is an 8-bit binary value that indicates the remaining life of the packet. The detail value is decreased by at least 1 each time the packet is processed by a router. Protocol. This 8-bit binary value indicates the data payload type that the packet is carrying. The protocol field enables the network layer to pass the data to the appropriate upper layer protocol. Example values are 1ICMP, 6TCP, 17UDP. Type of service. The type of service field contains an 8-bit binary value that is used to determine the priority of each packet. Fragment offset. A router may have to fragment a packet when forwarding it from one medium to another medium that has a smaller MTU. More fragments flag is a single bit in the flag field used with the fragment offset for the fragmentation and reconstruction of packets. Down fragment flag is a single bit in the flag field that indicates the fragmentation of the packets is not allowed. If the down fragment flag bit is a set, the fragmentation of this packet is not permitted. Other IPv4 header fields version contains the IP version number 4. Header length specifies the size of the packet header. Packet length. This field gives the entire packet size including header and data in bytes. Identification. This field is primarily used for uniquely identifying fragments of an original IP packet. Header checksum. The checksum field is used for error checking the packet header. Options. There's provision for additional fields in the IPv4 header to provide other services, but these are rarely used. The most significant network layer, OSI Layer 3 protocol, is the Internet Protocol. IP version 4 is the network layer protocol that will be used as an example throughout this course. Layer 3 IP routing does not guarantee reliable delivery or establish a connection before data is transmitted. This connectionless and unreliable communication is fast and flexible, but upper layers must provide mechanisms to guarantee delivery of data if it is needed.